Hello dear students, welcome all to this new video. In the previous video, we discussed about the dihydroxylation reactions using KMnO4 or potassium permanganate. Here in this video, we are going to discuss about the dihydroxylation using osmium tetroxide. That means the dihydroxylation of alkenes using osmium tetroxide, it is OSO4. Okay. For that we are taking one example. This is the example RCH. If this is the alkene here, RCHR. This on reaction with the osmium tetroxide. Osmium tetroxide will be like this. Okay, this is osmium tetroxide. In osmium tetroxide, the oxidation state of osmium is 8. Okay, this is the highly oxidized state. Here the mechanism will be like this. Using this pi electron, the attack on this oxygen like this bond shift like this, and using this oxygen and this bond attacks to this carbon and forms a 5-membered osmate ring, that is RCH and here forms a bond with carbon and oxygen, here osmium and double bond O. This is a 5-membered osmate ester. This is an osmate ester formed. Okay, osmate ester which undergo cleavage or heterolytic cleavage to give a cis diol as the product. Okay, under reducing conditions. Okay, if we can use H2O2, we can use hydrogen peroxide and THF in presence of tetrahydrofuran. The product you will get like this: RCH, CHROH. So cis diol is formed. This is a cis diol. It's a vicinal cis diol plus the byproduct will be osmium tetroxide. Will be OH. Here you must remember the oxidation state of osmium here is only 6. So this osmium is reduced to osmium 6 compound, and you will get a product as this one. This is a cis diol. So osmium tetroxide is an oxidizing agent which used for dihydroxylation of alkenes, and secondly cis hydroxylation occurs here in using osmium tetroxide. And third point about osmium tetroxide is a toxic reagent. It's a toxic one and also is a volatile. It's a toxic and volatile, and lastly is an expensive reagent. Osmium tetroxide is an expensive reagent used for the dihydroxylation reaction of alkenes. Another example for this dihydroxylation reaction using osmium tetroxide, this is the example. This is cyclohexanol in presence of is on reaction with the osmium tetroxide. Okay, osmium tetroxide. The attack will be like this one, like the forms, and first step there forms an osmate ester. This is the osmate ester. OS, here double bond O, here is double bond O. In the next step, this osmate ester on reaction with the water on a hydrolysis in presence of tertiary butanol, it gives a cis diol. Diol will be like this, OH plus osmium OH. Here the oxidation state will be 6 for the osmium. Here is the oxidation state is 6 and here is the oxidation state is 8. So the osmium is reduced to this 6 oxidation state and diol is formed as the product, and here we know that this osmium tetroxide is an expensive one, okay, is an expensive and also toxic one. So in the reaction of alkenes with the osmium tetroxide or dihydroxylation reaction, we use catalytic amount of osmium tetroxide, okay, we use catalytic amount of osmium tetroxide in presence of some co-oxidants. Some co-oxidants are used here. The co-oxidants may be metal chloride. Some metal chloride are used as co-oxidant. That may be sodium chloride or barium chloride, etc. Sodium chloride or barium chloride, etc. Or maybe use H2O2 hydrogen peroxide, or you can use tertiary butyl hydroperoxide. What is the role of these co-oxidants here is this co-oxidant reoxidizes this osmium 6 species into osmium 8 species. So this catalytic cycle continues. What is the role of this co-oxidants, that may be metal chlorides like sodium chloride or barium chloride, hydrogen peroxide and tertiary butyl hydroperoxide is, its role is it reoxidizes the hexavalent or the osmium with the 6 oxidation state into osmium with the 8 oxidation state. Okay, that means the octavalent osmium. That is, it regenerates this co-oxidant regenerates this osmium 8 species from this osmium 6 species. It regenerates this osmium 8 species so that this catalytic cycle continues. So in the first step there is osmium ester is formed, then it gives so under reducing condition or hydrolysis it gives the product, that the diol is formed as the product, and this osmium 6 species is formed. This osmium 6 species again reoxidized to osmium 8 species by these co-oxidants like metal chlorides like sodium chlorate and barium chloride, hydrogen peroxide and tertiary butyl hydroperoxide, etc. Now we are going to check some other examples of this dihydroxylation reaction. First example, this is the example. This is the compound which on reaction with the osmium tetroxide in presence of hydrogen peroxide and acetone. Okay, in presence of hydrogen peroxide and acetone, the product will be like this. Here is OH, here is OH because dihydroxylation occurs at this double bond, and here this becomes COH. Okay, here this becomes COH and COH, and the yield of this is only 31%. Next, another example. This cyclohexene, this is on reaction with the osmium tetroxide in presence of sodium chloride, that is NaCl4 and H2O. It gives the dihydroxylated product, that is OH and OH. This is almost 73% in yield. Okay, another example. This is the compound. This on reaction with the osmium tetroxide, H2O2 hydrogen peroxide and bar H2O. The product formed will be OH, another OH, here dihydroxylation occurs, and here is another OH. Okay, here dihydroxylation occurs and this product will be formed. So these are some examples for osmium tetroxide dihydroxylation reaction using various reagents. Actually, this osmium tetroxide is in electrophilic in nature. Okay, electrophilic in nature. If an electron withdrawing group is present in the alkene, okay, if this is the alkene, there is electron withdrawing group is present, This may retard the dihydroxylation reaction because this electron withdrawing group decreases the electron density here. This osmium tetroxide is electrophilic in nature. Okay, so the presence of electron withdrawing groups on the alkenes may retard the rate of dihydroxylation reaction. Another point you must remember about this dihydroxylation is, if this is the compound, here is a double bond, here is a double bond, and here is COH, here is a COH group. You can see here two double bonds. Here is a one double bond, and here is a one double bond. And if this reaction with osmium tetroxide in presence of H2O and acetone, okay, dihydroxylation occurs here. Where the dihydroxylation occurs, here or here. Okay, you must remember this is electrophilic in nature. So where the electron density is more, there occurs the dihydroxylation reaction. Here you can check. This is a one double bond, here is another double bond, here is a electron withdrawing group, COH group is here. So here electron density is less, and here this is the more electron density. So the product formed will be COH, here is COH, and here is OH, here is OH. The dihydroxylation occurs at double bond with more electron density. Here is more electron density, so dihydroxylation occurs here. So this is all about the dihydroxylation using osmium tetroxide, that is its reaction, that is mechanism of the osmium tetroxide dihydroxylation, using then use of the co-oxidants like metal chlorides, hydrogen peroxide, or this tertiary butyl hydroperoxide, etc. Then examples of this cis dihydroxylation using osmium tetroxide. Thank you.